Hello, welcome back. In this lecture, we have been talking about flex shrink stylings, and we have applied flex shrink to the first and the last element. In this lecture, we'll continue with the flex basis because, in my perspective, this is the most confusing one, especially when you are combining it with the flex grow. Okay, so let's start here in our CSS file. First thing, I will get rid of all of the flex grows here. I will keep here just one maybe, yeah. Let's remove the flex string here. And actually, no, let's remove the last child, and also we can remove the flex grow one here. Let's keep here first child because we'll be using it still. And let's remove here also all of the flex grow and the flex strings and just solely apply the first child flex basis. Flex basis of 400 pixels. So what does it mean? This will assign a default size of the element will be 400 pixels before the empty space is distributed. So basically I will override my 200 pixels and I will assign to first child 400 pixels, so it will be larger. You'll see now the first item should have a 400 pixels. So when I will inspect this, it should have 400 pixels. And we will see. It has a 400 exactly pixels, this item. Okay, and that's entire thing with the flex basis. You can see when we are shrinking the screen, make it smaller. Of course, every item is proportionally shrinked now, and that's why the first one is larger, because it has a larger flex basis, of course. And the flex basis you can assign also the other units. You can, for example, say here 50% like this, and this will be this item will take 50%. So that's a flex basis. It gets a little bit confusing when you are trying to apply also flex of 1. So flex grow will be 1, then it can get a little bit more confusing. So let's see example when we'll be applying the flex grow to the 1 and also together with the flex basis. Okay, let's go back to our coding editors. All right, and let's apply here flex 1. Okay, so flex grow is apply to every element the same, and also flex strength. And let's target here our first element, this first child, and let's apply here flex basis. All right, let's see what the flex basis will try here. Let's say 200 pixels flex basis will be. Okay, so first child, the flex basis 200, and now let's see the results. We have a flex 1 of all of our children, so the empty space should be distributed to all of the children, and the flex basis of the first child is 200 pixels. Let's see what will happen. Okay, you can see it's distributed proportionally to these last 3 items, but the first item with the flex basis 200 has a larger width. Let's see. I will see here what width we are applying, and we are applying exactly to this element 568 pixels. Actually, let's remove the margin. Let's remove the margin of all of the elements, so it's not so confusing, because the computations with the margin will be a little bit different. Let's remove margin, completely margin. Okay, so now it seems like a 1 element, but we have here 4 elements. But let's see the first one. Now it has a width of 570 pixels, and all of the items have a 370 pixels. So how the flex basis is applied? You can see the first item with the flex basis 200 is exactly 200 pixels larger than other ones. This one has a 570 pixels, other ones have a 370. So all of these 3 ones are proportionally assigned, and the first one is 200 pixels larger, as we have defined here. So we should be able to figure it out by math. First, let's inspect how big is the width of the screen. You can see my width of the screen, this div here, is 1680 pixels. So the size of the viewport here, you can just inspect the screen and simply you will go to this div or to the entire HTML here, and you will see here 1680 pixels is the width of my screen. Okay, let's get back. And let's apply some math here, okay? So I'll write in a commented area here. I'll write comments. And let's see example. So our flex basis is a 200. So we have a 1680 pixels is the width of my screen. Minus 200 pixels reserved for the first item, which is a flex basis of the first item. Minus 4x. All right? Equals 0. Okay, so how I got to this equation? Okay, so when we want to distribute it, okay, so let me get the basic equation. So we have a 1680 pixels width minus 3 items has to be equal distributed, so minus 3x. X will be these items, these 3 items here, that has to be the same width, minus 3x. Okay, we should get to the 0 because all of the space in the width when the flex 1 should be distributed, so that we should get to the 0. Okay, we should get to the 0. Okay, so minus 680 pixels, x representing the element, and now minus x, this will be like this, minus x plus 200 pixels. Okay, like this. This is the item, this is my item, this first one, which should be 200 pixels larger. So we have a entire width minus equal distribution to the 3 items minus x plus 200. This is this item, which should be 200 pixels larger. When you will transform it, you will see it's a 1680 pixels. 3x minus x is a 4x, and 1680 pixels minus 200 will be 1480 pixels. Okay, because minus sign in before of this parentheses will change the signs inside of the parentheses, so this will be minus x. Actually, I will write it again. Okay, so minus 3x minus x and minus 200 is equal to the 0. Okay, so this is 1480 pixels minus 3x minus x is a 4x minus 20 equals 0. All right, and actually this is already, we have this, so minus 680 minus 200 is 1480 minus 4x equals 0. All right, so now we can count the items. So we have a 1480 pixels minus 4x, so this is 1480 pixels equals 4x, and now we can just simply, we can divide it. Okay, so let's divide these items. So calculator, 1480 divided by 4, and you will see now that every item should have a 370 pixels. In the case the screen set will be 1480. Remember, our screen is 680 pixels. We counted with the example when the first item taking 200 pixels more. So now x is equal to 370 pixels of every item, but remember, our first item has a plus 200. Okay, so does it match? Does our item has a 370? Yes, all of the other items has a 370. You can see there 370, 370. You can see it under in this div child, and this one 570. So that's the simple computation for it. Okay, so remember this flex basis is 200 pixels, and the same will apply when I will apply also flex basis of percentage wise. Okay, so if I will decide here, I will comment it out, and I will decide here to place here flex basis of 20%. Okay, now let's see what will be the size. So now the size will be 672 pixels, and here will be 336, 336, 336. So let's see how this will apply in the case of the percentage. Okay, so I will go back to colligator. Okay, and let's write it above. Oh, yeah, let's write a commented area. Okay, so first thing we need to figure it out how much is 20% from our screen size. In my case, 1680 pixels. So 20% from 1680 pixels, 680 pixels. So 10% is 168. 20% is times 2. So this is 336, right? So between 336, 20% from 1680, because it's just basically this 168 times 2. Okay, so 20% is this. Okay, then we have our screen size 1680 minus this reserved spot for the first item 363 minus 4x equals 0. Okay, this we have 1344, right? 1344 equal 4x. Divide by 4, so 1344. Okay. Okay, divided by 4, 336, and you can already see the result. Okay, so x 336. Plus 200 reserved for the first item. So normal case, every item should have a 336, 336, 336, 336, plus 200, plus 20% reserved for the first item. So this is 336. This is 336 plus 336. All right. 336 plus 20% reserved for first item, which is 672, right? 672, and 336. Yeah, everything is matching. So that's the, for example, 20% flex basis. And that's the explanation of a flex basis. So you can see in the case when the flex 1 is not applied, so the empty space is not equally distributed. It's very simple case. When when the empty space is distributed, the computation is slightly different because the items has to grow proportionally. The empty space has to be taken. All right, guys, so that should be it from this lecture. In the next lecture, I will show you just how we can center out the content on the screen, and that's gonna be it. So see you in the next one, guys. Cheers.